Hello guys, today we're going to be moving on to a new topic. So we spoke about this a little bit coming into the average rate of change. Today we're going to be looking at difference quotients. So this ratio that we're given here is called a difference quotient, or it's also related to this average rate of change. And the reason we call it a difference quotient is it's like our slope formula, but rather than having an x1 and an x2 value, we think of x as just having a small value h added to it. And then that becomes the difference on the bottom of the two x values. It's just this small change in the value of x, which is our difference. So here we have an example, and we want to find the difference quotient of this function, 5x minus 1. Here's our difference quotient formula, f of x plus h minus f of x divided by h. So first we want to plug in, if you recall anything that's in the parentheses like this, it's asking me to actually plug in x plus h into my function I started with. So to calculate that value, here I've got 5, and I'm going to plug in x plus h, and we're still subtracting that minus 1, right, that came from our original function. So I've got this expression here, 5x plus 5h minus 1. Now we know from our first slide that this is that difference quotient formula here, right? That's what we need to calculate. So we just looked at this, 5x plus 5h minus 1, that was f of x plus h. But we still need to subtract from it f of x, which was 5x minus 1, and we're dividing that by h. So let's go ahead and think about this. Well, if we've got 5x and we're subtracting it from 5x, these two terms will cancel. I have a minus 1 here, and this negative negative is going to make this become a positive 1. So these 1's cancel out. So indeed, I'm just left with 5h over h. And then my h's can cancel because I have 1 on the top and the bottom of my fraction. And I'm left with 5 as the computed difference quotient of 5x plus 1. Right? If we add a small value to that function, this is the quotient that we get from that. Now let's look at a little slightly more difficult example, because this one involves a quadratic function, which means we've got to do a little bit more with x plus h to find the function value for it. So let's come down here. So here's our function, x squared plus 2x minus 3. And anywhere we have x in there, we're plugging it in. So we've got to be a little careful right on that square, because this now is something that needs to be FOILed. And they've kind of skipped that step, so I want to write that out here. Recall that if we have x plus h squared, that's equal to x plus h times x plus h. And then that needs to be FOILed, right? Our first, the outside and inside pair, and the last pair, right? First, outside, inside, and last. We need to FOIL it. So the first two terms multiplied together is x times x. So we get an x squared. The outer two terms will give me x times h. Since x is our variable, I'm going to write hx. My inside terms, h and x, will also give me that same value, plus another hx. And then the last is h times h, so h squared. So from FOILing that, we get this x squared plus 2hx plus h squared, and we can see that here, right? This, what we got from the FOIL, ended up over here. Then, when we plug into 2x, we still have to do that, right? This was just for this first x squared term that we had in our function, this one here. Now we need to plug in 2 times x plus h, right? That gives me this 2x and this 2h, and then we can't forget our constant, right? So this entire expression right here, that is what we get when we plug x plus h into our quadratic. But we're not done, right? This was just computing f of x plus h. Now let's recall we've got our formula here for the difference quotient, f of x plus h minus f of x over h. So everything from here all the way down to minus 3, this is what we computed on the last page. This is that just f of x plus h. Here we're subtracting f of x, and then it's being divided by h. Now here they've shown us, right here we've got our distributed negative into these values. And if we notice, we're now going to start getting some opposites, right? I have x squared here and minus x squared, so those can cancel. I have a plus 2x and a minus 2x. Those can cancel. I have a minus 3 and a plus 3. And those can cancel. And now let's look. We've got just terms that are left with h values in them. And since I can see an h here and an h in every one of these, then I know that I can definitely factor an h out of this expression, right? That's what's happened here. They factored out one h from that. And we are ended up with h times 2x plus h plus 2 over h. And then, of course, these h's can cancel, so we get a final difference quotient of 2x plus h plus 2. And this is a really good example that difference quotients quite frequently do not always come in terms of x. Sometimes they will still have that h in there. So even though in our previous example, the h was totally canceled out, and let me pull that up just for 1 second here. But if we recall here, this one we calculated a value of 5 for the difference quotient. And here it's this entire expression. So be careful with that you will still have h's in these. That's all for my lecture portion. Please look at my other video for examples.